to do this example. So what does step 1 say to do? Factor, find the domain, find the intercept, right? Here we go. So we are going to factor. Zach, are you done?
Yeah.
With number 7?
Yeah.
Okay, so let's start by factoring. Is the numerator already factored? Yeah, so we have x minus 1 on the top, and then on the bottom, what are the factors going to be? X minus 2, x plus 2. Okay, now how do we find the domain? What's the domain? Find out what it can't be. I don't see any duct tape, any volunteers. I can't do it legally. I am really tired of their little social
I'll do it.
Okay, but then I get to let them tape you guys.
Wait, who's gonna do it?
Let's have a taping party.
I would just prefer that none of my tape gets used. Okay, so what's the domain? X cannot equal what? Why those numbers? They would make the denominator 0. Okay, now we find the y-intercepts. How do we find, or sept, there will only be one. How do we find the y-intercept? Plug in 0. So it'll be negative 1 over negative 4, which is 1/4. Okay, there's step 1. Not hard. Yes, these are long problems. I didn't assign very many, did I?
Yeah, you did 24.
10. There's 10. Wait, no, 11. 11. Okay. Number 2. What does number 2 say? Find the zeros of the numerator. Okay, so the numerator is x minus 1. So what's the 0?
1.
So x equals 1. What do we call that point? That is an x-intercept. Okay, step 3. Find the vertical asymptotes. Before you find the vertical asymptotes, remember how you have to reduce? I should have put that in my list to make sure you've reduced your fraction first. So look at our fraction. Can we reduce it first?
No.
There's nothing that will reduce. So where are the asymptotes?
+1 ±2.
X equals positive 2 and x equals negative 2. Those are vertical asymptotes. Okay, step 4. Let's look at the degree. So on the top we have degree 1. On the bottom we have degree 2. So what does that tell us? That means there's a horizontal asymptote at y equals 0. That's rule number 1. Okay. So now we graph everything. Dun, 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 dun. Okay. Domain, y-intercept. So the y-intercept is at 1/4. So in order to graph a 1/4, I'm making myself really big graph paper here. Okay, so the y-intercept 1/4 will be like right there, correct? Okay, then we do x-intercept. This one only has one x-intercept. Sometimes there's more than that, but there's only one x-intercept right here. Now we do our vertical asymptotes. So there's a vertical asymptote here at 2, and there's a vertical asymptote here at negative 2. Then we do our horizontal asymptote. Now here's something I never talked to you about before. Remember how asymptotes are lines that the graph gets close to but doesn't quite get there? The graph will never cross vertical asymptotes. However, sometimes the graphs will cross a horizontal asymptote. What do you notice right here? Where is the x-intercept?
It's on there.
The x-intercept is on an asymptote. That is possible. It is possible for the graph to cross a horizontal asymptote. Now, do we really have enough points here to really know what this graph looks like? No. So the last part of step 7, I had you skip step 5 and 6, which kind of is this next thing, sort of, only more complicated. But I had you skip steps 5 and 6, and instead I added this to step 7, which is find other points if you need to. Okay? So I would really like some kind of information about what's happening here. It might not hurt to know more about what's happening here, and I really want to know something happening over here. So what points would be really good to plug in? -3, -1, and a +3? And then, so I can start with that, and then I can plug in more points if needed. So let's start with those 3 points, and that will tell me a little bit about what's happening. Okay, so I need to go to my original problem, or you can use the factored version, it doesn't matter. So I'm going to go -3, I'm just going to do my little work over here. -3 minus 1. Hopefully you've all written that down already so you can see it, so I can put this where you can see it also. And then -3 minus 2 times -3 plus 2. Okay, what's -3 minus 1? -4. -3 minus 2 is a -5, and -3 plus 2 is a -1. So I end up getting negative over a positive, so -4/5. Does that sound right? So at -3, there's a point at -4/5. Now 1 point is enough because we have asymptotes here. So the asymptotes pretty much tell us the shape of the graph. I just wanted to know whether that part of the graph was going to be above the asymptote or below the asymptote. So from that 1 point, can we kind of tell that our graph is going to be in here somewhere? So you could plug in other points if you wanted to, but I'm fine with you just kind of like guessing that that's where the graph goes. Does that make sense? Now we plug in a -1. So let's see, I got a -4/5 for that one. Okay, so now I'm going to plug in -1. So -1 minus 1 over -1 minus 2 times -1 plus 2. So that gives me a -2 over -3 times 2, no, times 1, sorry. So -2 over -3, isn't that a positive 2/3? Okay. So positive 2/3. So at -1, our graph is going upward to positive 2/3. So now I have 3 points in here, and just because I've had experience graphing these, which you guys will kind of get with more time, I am guessing that the graph is going to kind of look something like this. And you're probably thinking, well, how did I know that? Well, you could plug in more points if you want to. It's just you get, after you've done enough of these, you begin to recognize what it's going to do. Okay, last point is 3. So we're going to go 3 minus 1 over 3 minus 2 times 3 plus 2. So that gives us a 2 over 1 times 5. So 2/5. Does that look right? Did I do that okay? So at positive 3, the point will be up positive 2/5. So it's going to be above the asymptote. So that's enough to kind of show us that the graph will probably be in here. There's our final answer. Now, the last thing I said you could possibly do is to check it with your calculator. So let's do that. So I'm going to type in x minus 1, and you really should put that in parentheses, divided by, I'm just going to put the original problem, x squared minus 4, because then I don't need as many parentheses. So I'm typing the original problem in, oh, you can't even see it. There you go. See how I just typed in the original problem. Make sense? Okay, so now I'm going to hit graph. Okay, now that looks sort of like our graph, but a little bit strange. Any ideas why it looks a little strange? the asymptotes. Right now, our calculator is in what's called continuous mode. So it tries to connect everything. Even though there's no points at the asymptotes, it still tries to connect. And so it ends up making little heartbeat things where the asymptotes should be. Okay? One way to avoid that is to go to mode and change connected mode to dot mode instead. That way it'll just graph individual points instead of trying to connect the points. Okay? But then you still are lacking a lot on your graph. Do you see how you can still kind of get the bare outline of the graph without the asymptotes, but you're still really, it's kind of weird? This is why you really need to understand these properties and do these without using the calculator, and then just use the calculator to check your work, because the calculator's not going to do it for you.
It works on the iPod.
Oh, lovely.
Yes.
I'm not sure to be if I should be excited or disappointed. All right. Do you want another example, or is that good?